sides in a triangle, going to take some multiple steps. Just wants to find each missing length rounded to the nearest hundredth. So in this triangle, I'm only trying to find this side from W to Y. And so if I had one of these side lengths, I could use SOHCAHTOA from this angle since it's a right triangle, but I don't. So then I'm gonna have to work backwards and say, okay, well, they've given me this big triangle and this oblique triangle right here. And that's the one I'm gonna have to use because with the whole big triangle, all I know is this 18 degrees. I don't know this whole side, I don't know this side, I don't know this side. So I can't do anything with it. But looking at this oblique or non-right triangle, I've got this 18 degrees across from this side that is also the hypotenuse of the smaller right triangle. And so if I knew this angle across from 2.7, which is actually all the way up here at angle Z, I could do law of sines. And so I can figure this out because I've got this triangle would have 180 degrees total here. So I can do 180 minus 18, and I could figure out what this is because this is a linear pair here. These two angles make 180. So 180 minus 42 is 138. And so I'm doing 180 minus 18 minus 138. And I get this angle here to be 24 degrees. Okay, so first step, law of sines. And so I'm going to put my sine of 18 degrees over its opposite side x equals sine of 24 degrees over 2.7, cross multiply divide, and you should get 2.05 when you round to the nearest hundredth. Okay, so now this is this side right here. So now I can work in this triangle, this right triangle, and I'm trying to find this side or this leg, which is adjacent, and this is my hypotenuse. So that would be a cosine. So step 2 is just SOHCAHTOA. And so I would have cosine of 42 degrees equals adjacent, I'll call it y, over 2.05. I'll steal that decimal again. So remember that you're just going to multiply by this number to cancel that out. Okay, so we'll take that. Oop. Times cosine of 42. And we get 1.52. All right, number 2. Different picture, but still two triangles. Same thing in here. If I wanted to find this in this right triangle, if I knew one of the legs of the hypotenuse, I could find it, but I don't yet. So then my next thoughts are, can I do a law of sines? The only side length I have is this 210. I can find the angle across from it is here. So looking at this whole triangle, ignoring the line down the middle, I know these two corners here, and so I could do 180 minus those to find this whole angle up here at Z. And so that's 47 degrees. Okay, so does that help me? I could have this across from here, and then yeah, I just need one of these sides here, so I could do this side. So I could have sine of 47 over 210 equals sine of 82 over x. What does that get you? We got 284.34. Now working in this right triangle, I just do SOHCAHTOA. So law of sines was step 1. SOHCAHTOA is step 2. Again, I have adjacent that I'm trying to find, and they are giving me the hypotenuse. So I'm going to use a cosine of 51 equals y over 284.34. So I'm just multiplying that times the cosine of 51. And it should get 178.94. Definitely not drawn to scale if that whole thing is 210, but that is our answer.